Greetings, fellow mathematicians. We're going to take a look at a second way to evaluate this limit by factoring. Now, the simpler or more obvious way to do this is by multiplying or expanding 2 plus h cubed, but since 2 plus h is cubed and 8 is a perfect cubed, 2 cubed, we can apply our sum and difference of cubes formulas. Now, it's totally fine if you don't have these memorized, because again, we did evaluate this by expanding, but maybe you know these formulas, and this gives you a quicker way to go through this than the tedious algebra of multiplying 2 plus h cubed out. All right, now here, since we have the minus, we're going to be using the difference of cubes formula, and we're going to identify x as 2 plus h, and then 8, that's our other cube, we're going to identify y as 2. So let's go ahead and basically factor the numerator, 2 plus h cubed minus 8. Just for emphasis, I'm going to write the 8 there as 2 cubed. So we see the subtraction of those two perfect cubes. All right, now to use that formula, we're just going to plug in. We're going to think of this as being x cubed. So x is going to be 2 plus h. And then y cubed, we're going to think of y as being 2. And from here, we just have to plug x and y in, but you have to know the formula. So if we go ahead and do that, your first term here, you get x minus y. So that's going to come out to be 2 plus h minus 2. Again, you can cancel the 2's out. Maybe you're quick with that, but we'll do that in the next step just to take our time. And now we plug in everything to the other part here, x squared plus xy plus y squared. All right, so we have x squared, so 2 plus h squared. We add to that x times y, so 2 times 2 plus h. And then we add to that y squared, which is 4. All right, now this is still a little bit tedious because we can simplify that second part, but notice here, the 2's cancel, leaving you with a factor of h. And if you go ahead and expand, again, I'll take my time, properly expand that, don't square each term, we're going to get 4 plus 2h plus 2h, so 4h plus h squared. Here I'm going to distribute that 2, so we'll get 4 plus 2h, and then we have the plus 4 by itself there. All right, and if you go ahead and combine like terms in the parentheses, looks like we have h squared by itself. Looks like we have 4h and 2h, 6h, same as before. And notice the constants, 4, 4, and 4, that's 12. So we arrive at pretty much the same end result, but it is only shorter because we were making use of the difference of cubes formula. All right, so now we can just plug that in. That is basically the entire numerator. The limit of h is still approaching 0, and we have the numerator now as h times h squared plus 6h plus 12, and that's over h. And again, you can cancel those factors of h out, and we're left with, same as before, limit as h approaches 0 of h squared plus 6h plus 12. And same as before, plug in h as 0 here since there's no indeterminate form, and you'll get your limit as 12. And this is, again, a different way to evaluate this limit. I can't say it's any easier or harder. It just depends on if you know your sum and difference of cubes formula. As a calculus student, these are good to know for the remainder of the calculus sequence. So if you didn't know them before, memorize them now. Hope you enjoyed the video. If you did, support the channel, like and subscribe.